Hello again, class. This is the math classwork video, and this is a shortened version of what we would actually be doing in class. It's able to be shortened because you have the advantage of going back and rewatching things and working at your own pace. I'm going to try to stay concise to be respectful of your time, but this is new content. This is the beginning of topic B about equivalent fractions, and today we're going to be talking about decomposing fractions into equivalent fractions using a number line and a tape diagram. So this is the first time we've talked about this, and so I will be explaining everything in the video, and I hope that that's helpful. Okay, if you are watching this video, you should have read the description attached to this video in Google Classroom that reminded you to get your apply book and open up to those page numbers. I don't have them right in front of me, but those are written in the Google Classroom description of this video. And if you don't have your apply book, that's all right. Just make sure you have a blank piece of paper because you will be held accountable for the work that is in that apply book on those pages when we get back. The first part, you don't need your apply book yet, so you can set that to the side. What you do need is a place to write and a pencil. We are going to go through, and I'm going to teach you an example of one problem. Then I'm going to get you started doing it on your own. You're going to pause it, see if you can do it on your own, and then we'll check that problem. Kind of like we would do in class, but like I said, shortened, and I cut out our review for the day. All right, let's get started. So this question is what we're going to look at first. Right now, all you need to do is watch what I'm doing while I talk about it. I'm going to read the prompt. It says, rename each fraction by decomposing it into smaller unit fractions. Label the number line to show the decomposition and write an equation to express the equivalence as a sum. I read that and I think, oh my goodness, I hope all of these kids have been listening when we've talked about all of these vocabulary words. So we have rename, which is to say a different name for a fraction. We have decompose, which is to break down into smaller pieces. We have unit fractions, which is one piece. Unit fractions are one piece. We say that a lot. And we are going to write an equation to express 1/2 in a different way is kind of what it really is. We're going to write 1/2 in a different way. So let's start by labeling our number line. Our number line is written nice and neat for us, and you just have to watch for this first one. 1/2 is in between the whole numbers 0 and 1. So all I need is a 0 and a 1. The fraction 1/2 is also has a denominator of 2. So we're going to split our whole into 2 parts and label that middle part 1/2. So now we're decomposed into halves. I'm also going to go ahead and shade what 1/2 looks like on the number line. So it goes that far. Here's my 1/2. Now, for the new part, we have drawn fractions on number lines before, but this time it wants us to decompose into a smaller unit fraction. And I'm going to show you how we're doing that. I'm going to grab a different color, and we are going to break apart 1/2. We're going to start by breaking apart 1/2 just in half again. And this different color is going to show what that looks like. So I split that half in half, and I'm going to split this half in half as well. That bluish purple line shows where we decomposed or broke down this fraction of 1/2 into smaller pieces. Now I want you to notice how many parts my number line is broken up into. It was broken up into 2 parts, but then I split those 2 parts in half, and now it's broken up into 4 parts. So let's go back to our 1/2. Now the 1/2 that was shaded in from 0 to 1/2 is split in half again. and we can relabel those pieces as new unit fractions. So now that our purple has split our number line into 4 parts, the new unit fraction is 1/4. Each of those little bumps split up by my new purple lines are 1/4, 1/4, and 1/4. If we were in class, I would have us getting out our manipulatives and showing how our 1/4 sized pieces fit exactly 2 of them into a 1/2 sized piece. But unfortunately, that's not where we are, and that's not what we're doing. I wish it was. But if you took 2 of those 1/4 pieces we always get to use in math and lined them up with one 1/2 piece, you could see that they were the exact same size. So we have labeled our number line to show the decomposition of a 1/2 into smaller parts. And we can write the equation by saying that 1/2 is equal to 1/4 plus 1/4. We couldn't say that 1/2 is equal to 1/4 because they aren't equal, but we need 2 1/4s to show equivalence. So I'm also going to shade in on the bottom to show that 1/4 right here and 1/4 right here also lines up. All right. I hope that made sense. Like I said, I wish that I could have our manipulatives with us. Let's keep going, and hopefully you'll be able to pick it up. Now we have 4/5. I'm going to start by labeling my number line with a 0 and a 1. 4/5 is in between 0 holes and 1 hole. Next, I'm going to split my number line up into fifths. 5 parts. I did 5 parts because we have 4/5 here. I'm going to label the bottom lines of my number line 1/5, 2/5, 3/5, 4/5, and we can put 5/5 with our 1 hole. So there are some nice little number line labels for us. We're doing the same thing where we're going to decompose our fraction into smaller parts. So 4/5 goes to right here. And what we need to do is break our 4/5 down into smaller parts. I'm going to do that by picking a new color. Let's do this bright color. And each of my 1/5 pieces is going to be split in half with a different colored line. So now we used to have 5 sections, and now we have 5 sections, each split in half, for 10 sections. I'm going to go through and label those sections in a different color, but this time we're talking about tenths. So our 0 holes is the same as 0/10. Then we have 1/10. On the 1/5 line is the same exact spot that we will get 2/10. 1/5 and 2/10 are actually the same. And if we had our manipulatives, I would have you grab 2 little 10th pieces and hold them up next to 1/5 piece, and you could see that they were the exact same size. Let's keep going. 3/10. 4/10 is the same as 2/5. 5/10. 6/10 is the same as 3/5. 7/10. 8/10 is the same as 4/5, and 9/10. And 10/10 is the same as 5/5. 5/5 and 10/10 might be the easiest one for you to see that they're equivalent fractions. 5/5 equals 1, and 10/10 also equals 1. So you should definitely be able to see that. And like I said, if we held up our shapes that we have in class in your little buckets, they would all line up like this. So we have decomposed 4/5 into smaller parts. Let's count the number of tenths that make up 4/5. So we have our 4/5 shaded in green, and now I'm going to grab a light blue, and we're going to see how many tenths are in 4/5. We have 1, 2, 3, 4, 5, 6, 7, 8 tenths. 4/5 and 8 tenths are also written on the same line of our number line. So 4/5 is equal to 8 tenths. I'm going to go back to our directions to make sure that we do everything that they're asking us. Rename each fraction by decomposing it into smaller unit fractions. So we are going to write 4/5 is equal to how many tenths? 1/10 right here, plus 1/10 right there, plus 1/10 right there, plus 1/10 right there, plus 1/10 right there. And we should have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 8 tenths and 4/5 are equivalent fractions. And this is an equation that shows that. All right, so we did our number lines first. Let's scooch down and talk about an area model. This one might be a little bit easier for you to see. What we're going to do is start by shading in our area model to represent 1/4. So the area model represents one whole, and it's asking us to rename each fraction by decomposing it into smaller unit fractions. Use the area model to show the decomposition and write an equation to express the equivalence as a sum. So here's our square. The whole thing represents 1. I'm going to write that up there so that I have lots of space for it. And now I'm going to decompose this into fourths. Break it down into fourths. I'm splitting it into fourths because the fraction that we're using right now is 1/4. Then I'm going to shade in 1/4. I'm going to do it with blue. There is our 1/4. When you show a fraction in a tape diagram like this, or the area model, you can label 1/4 like that. This might be an easier way for you to see decomposition at work. Decomposition, we talk about this a lot, is breaking it down into smaller pieces. So I'm going to break this down into smaller pieces by essentially chopping it in half. So I used to have 4 pieces, but when I chopped it in half, I got 8 pieces. So now, if we're talking about these as 8 individual sections, right here, they used to be fourths, and now they're split into eighths. We can also label this blue section as 2/8. So we are essentially saying that 1/4, what we had shaded in at first in the blue, is equivalent to 1/8 plus 1/8. And again, if we had those shapes from our classroom, and I forget, I think the 1/4 are yellow. But if you had a 1/4 piece, and it said 1/4, and you took it out of your bag, and then I said, all right, now I want you to grab 2 1/8 pieces. You could line them up next to each other. 1/8, 1/8. And those 2 1/8 would be equivalent to 1/4. All right, now let's scooch down to the last one. This is where you're going to need your extra paper. Start by drawing a square on your extra paper. Then I want you to label kind of far away from your square that the whole thing represents one whole. Now let's look at our fraction. The fraction we're using for this one is 2/3. Show 2/3 on your square. You're going to break it up into 3 parts. And then you're going to shade in 2 of those parts. Now we're showing 2/3. What we need to do next is decompose this or break it up into smaller parts. So before we do that, label it 2/3. We can see 2/3. There are 3 parts and 2 of them are shaded in blue, and we labeled it 2/3. All right, now we're going to chop this in half. Swoop. Now, we used to have 3 parts. Think in your head, how many parts do we have now when we cut all 3 of our 3 parts in half? Swoop. It turned into how many parts? You should be thinking 6 parts. So now we have sixth. And we can see those sixths right here. 1, 2, 3, 4, 5, and 6. There are our 6 parts. Now I want you to think in your head, how many of those 6 parts are shaded in? How many of those 6 parts are shaded in? All right. If you know how many of those 6 parts are shaded in, write that right here. Label that section that was once 2/3 into how many sixths it is now. You should have written 4/6. 4/6. We have blue covering 4, 1, 2, 3, 4 of our 6 parts. So this is equivalent to 4/6. Okay. If you need to go back and re-watch me explaining this, I really wish that I had a better way to teach it to you. And if we were together in person, we would have our manipulatives out and we would be working on it. But I also want to reassure you that this is something we're going to continue working on and to just do your best. All you can do is your best. All right. Now we are going to look at another number line. This is question 5 of what would usually have been in your book. And it says label the number line with equivalent fractions. Then write an addition equation to show equivalence. All right, so what we need to do is we need to look at the difference between the green lines and the plain lines. So some of these lines are in green. Let's see how many parts the green lines have us broken up into. There are 1, 2, 3, 4, 5, 6 sections with the green parts. So that means that we are broken up into sixths. So I'm going to give myself a denominator of 6. And if we are looking at the 6 green sections, our red right here that shows us what fraction we're talking about is shaded in up to the 1/6 line. So our first fraction, the one that we see when we look at just the green lines, is talking about 1/6, since there are 6 sections. Now we're going to look at the other lines. The other lines are in the same place as the green lines, but there are also some in separate places. Essentially, what those black lines did was broke each of the green sections in half again. If we're looking at the black lines, our fraction number line has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did you know it was going to be 12 since each of our 6 sections were split into half? It is 12 because each 1/6 was broken up into 2 parts, and now the whole number line is broken up into 12 parts with the black lines. So I'm going to put a 12 as our denominator up here. Now, if our 12 sections are looked at with these black lines that I put in all of the gaps, how many 12ths are equal to 1/6? In between the 2 green lines right here, there are 2 12ths. 2 12ths. So we are essentially showing that 1/6 is equal to 2/12. If we were going to then write an addition sentence to show equivalence, we could say 1/6 equals 1/12 plus 1/12. All right, let's keep moving. This says label the area model with equivalent fractions, then write an equation. All right, so the first way that we're going to label our fraction is ignoring the dotted line. Pretend you don't see the dotted line. Now we're going to see how many rectangles this was broken up into before there was a dotted line. There were 1, 2, 3, 4, 5 big rectangles. So our denominator is going to be 5. And if you know, think to yourself, how many of those fifths are shaded in green? I hope that you thought to yourself 2/5 are shaded in. Now we can talk about the dotted line. We can go and break it up in half. Now we have more. And before you count, you should think to yourself, if we take 5 rectangles and split them all in half, we're going to have more rectangles, and it should be 10 rectangles. If you need to count them, absolutely do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rectangles in our whole now. So now that we use the dotted line, this is broken up into tenths. And I want you to think to yourself, it's not 2/10 shaded in. It's not 2/10 shaded in. How many tenths are shaded in green? You should be thinking to yourself, 4/10 are shaded in green. So there is our 2/5, which we labeled on the top, but when we split it in half, we showed that 2/10 2/5 is equal to 4/10. I'm sorry if I misspoke. We can see that 2/5 is equivalent to 4/10. It says then write an equation. It didn't tell us to decompose, but if you were going to do that, you could say that 2/5 is equal to 1/10 plus 1/10 plus 1/10 plus 1/10. All right, like I said earlier, we're just doing our best with what we've got. This is the first lesson in our fraction equivalence unit, and so we are just going to keep moving. All right, now you can open up to your apply book. I don't have the page numbers right here with me to remind you what pages they are, but that's posted in Google Classroom and on the checklist. It is the part of your apply book that has this 10 and the 7 on it. All right. I want you to do your best to complete all of this page with question 1 and question 2, and then do question 3. For question 2, what you should do is write a square, draw a square rather, and label 2/4, and then figure out a way to also show 6/12. Do your best to do this on your own. Go ahead and pause the video now, and then come back to check your answers when you're done. Okay, I hope that you did your best to see if you could complete the work in the apply book. Now, let's check it. Question 1 says rename the fraction by decomposing it into smaller fractions. Label the number line to show decomposition. Then complete the equations. All right. We're using the fraction 3/4 here. 3/4 is in between 0 and 1, so we see 0 and 1 on our number line. It says that this line right here is the 3/4 line. You can kind of see that there's a little bit of difference in the darkness between the lines. So 3/4 can be seen in those darker lines. So there are 4 sections made by darker lines, and 3 of them are shaded in the pink. Now, the lighter lines break each of those sections in half to make them smaller. So now there aren't 4 sections, there are actually 8 sections. So this is 1/8, 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 and this is 1/8. Altogether, the pink is shading in 6/8. So the right answer for these boxes right here is 6/8. The pink is shading in 3/4 or 6/8, and it can be both because those are equivalent fractions. Over here, it shows the decomposition by unit fractions, and it wants you to put 1/8 plus 1/8 plus 1, hold on, 1/8 plus 1/8, 1/8, 1/8, 1/8, and 1/8. 2 1/8 equals 1/4, and so each of those all together makes the 3/4. What it wants you to write down here is what 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 is, or 6/8. So we have said that 3/4 is equivalent to 6/8. If you need to pause the video to write this down, you can. All right, let's keep moving. Next, it says, show that the fractions are equivalent by drawing a model. Then write an equation to express the equivalence as a sum. Here we have 2/4 and 6/12. So we started by showing ourselves what 2/4 would look like. That's okay. We know how to show 2/4 in a model like this. Here are our 2/4. Where it gets tricky is it needs us to show the equivalence between 2/4 and 6/12. 2/4 and 6/12 are equal, and so we have to show it by doing decomposition. Let's think for a second before we start writing. If I split all of these sections in half, I'm going to write this because I can erase it, but don't write this yet. If I split all of my sections in half, that's going to give me 8 sections. I don't need 8 sections for this one. I actually need 12 sections for this one. So instead of drawing just one line to decompose, I need to draw 2 lines to decompose. That will make it so that my square here is broken up into 12 parts. I'm going to highlight those 12 parts right here. There are my 12 parts. What you need to do is label the bottom of your tape diagram to show how 6 of those are shaded in. So before we drew our purple lines, it was 2/4. After we drew our purple lines, this was broken up into 12ths, and there are now 6/12 shaded in. So far, we have shown that the fractions are equivalent by drawing a model. Next, we need to write an equation to express the equivalence as a sum. So we need to write that 2/4 equals 1/12 plus 1/12 plus 1/12 plus 1/12 plus 1/12 plus 1/12. All right. I hope that you guys were kind to yourselves while you were working on this. We are doing this different than we would ever do it, and you just have yourselves to work on this with right now. No partners, no help from me, and I wish that I could help you and let you use the manipulatives to practice this. But again, I want to reassure you, we're going to keep working on this. Just make sure you have written down what I have written down, and we will keep working on it. I'm proud of you guys. And last but not least, we're going to do the remember section, which is the last part of your apply book. Number 3 says record the factor pair for the given number as a multiplication expression. List the factors in order from least to greatest, then circle prime or composite for the number. When we're trying to find all of the factors of a number, I like to list out 1, 2, 3, 4, 5, 6, 7, 8. And let's see if any of these numbers can be multiplied by something to get some factors. So 1 always works. We can use 1. 1 times itself. 1 times 17 is going to be a good factor. Now we think about 2. Will 2 work? In order for 2 to work, we have to have an even number, so 2 won't work. Now let's think about 3. If we counted by 3s, 3, 6, 9, 12, 15, 18. It would be 15 or 18, so 3 doesn't work. Same thing with 4. 4 times 4 is 16, and 4 times 5 is 20, so we can't get 17 with 4. 5, in order for 5 to work, it would need to, the number we were finding factors for would need to end in a 5 or a 0, so 5 doesn't work. 6 would either need to be 12 or 18, so 6 doesn't work. 7 is 14 or 21, so 7 doesn't work. And 8 is 16 or 24, so 8 doesn't work. And that means that the only factors we found were 1 and 17. I can write them in numerical order and make a rainbow like this, 1 and 17. And then numbers that only have 1 in themselves as factors have a special name, and that special name is prime. Prime means that a number can only be multiplied by 1 in itself. Not can only be multiplied. The only numbers you can multiply together to get that number are 1 and 17. So this is a prime number. Okay. That is all that I have for our classwork video for now. Thank you for following along. Make sure you hold on to these Apply Book pages to turn in when we get back to school. I hope you guys stay safe and warm out there. Thank you for being patient with me. Have a good rest of your day.